Hello guys, welcome back to VC Tech. Previously we talked about static routing in IPv4, how to manually configure a router to send traffic to a specific network using a defined path. We saw how static NAT gives us full control over routing decisions and how they are useful in a small network or a specific routing scenario where dynamic routing protocols are not necessary. Today we are building on that foundation, but this time we are moving into IPv6. Static routing in IPv6 works on the same principle. We manually define the path traffic should take to reach a destination network. However, the syntax and addressing structure are different because IPv6 uses 128-bit addressing. So, in this video, I will show you how to configure an IPv6 static route, explain the command structure, and also demonstrate how to verify that the route is working as it should. So with that being said, we are going to be making use of 3 routers for this tutorial and 3 switches with a few host devices. I've already assigned IPv6 address to all the interfaces on the router, and also on the local area network they've been assigned their link local address as well as the global unicast address. Now let's dive into the main objective for today's video, which is to configure static routes to enable host devices in different local area network communicate. So if we should go to the PCs right now and try to get IPv6 address, yes, we are able to get IPv6 address. Let's also try that on this local server. Try to get IPv6 address. Of course, we are able to get IPv6 address. Now let's do something else. Let's get the IPv6 address of the local server and try to ping from this local area network. Let's get the IPv6 address of this server, and we'll use one of these PCs to ping this server and see if we are able to communicate with that server. So on this server, we'll just go to ipconfig and get the IP address or the global unicast address of the local server. We just copy that. Then we head over to this device and we already have a global unicast address and also a link local address. Let's ping from this device. So we are going to be getting destination host unreachable because we've not configured any protocol that would enable the router know that this is where it's supposed to send the traffic to. So for this tutorial, we are going to be configuring static NAT, and we are going to start from this router to the last router over here. And always make sure to remember that when configuring static NAT, it uses the destination IP address and the next hop. That is how it works. Let's say we want to go to this local area network. So this local area network is the destination. So we say on this router, we go here and we say, let's go in configure terminal. So let's get into the main configurations. IPv6 route. If we try to query this, we are going to see that it is asking us for a destination IP address or destination IPv6 prefix. The destination where we want to go to, we have to put that IP address over here. So for this tutorial, we want to go to this network, and this network is using the global unicast address of 2030:830:1. So let's head over to this router over here and do that. So 2030:830:1/64. So after doing this, remember when configuring static NAT, we always use the next hop IP to direct the traffic. So the next hop IP from this router over here is going to be this router, and the interface is the one that is directly connected to it, which is interface gig0/2. So what is the IPv6 address of interface gig0/2? 2002 double colon BB9 double colon 100 double colon 2. So we are going to put the next hop IP here. The next hop IP 2002 double colon BB9 double colon 100 double colon, is that 1 or 2? I think that should be 1. That should be 1. All right, let's verify. So 2002 BB9 double colon 100 double colon 1. So 2002 BB9 double colon 100, that's 2. So this should be 2. By doing this, the traffic is no more on this router, as if this device or whichever device in this local area network wants to ping this device, previously the traffic was here because it does not know how to leave the local router to get to any router. But now that traffic has gotten to this router over here. We are also going to need to do that same configuration on this router, so it is going to recognize this router that it is directly connected to. So what we're going to do is, let's just copy this. It's the same. We'll just make few changes when we get to this router over here. So let's just do the whole configuration so you guys understand properly. So IPv6 route, the destination IP address, the destination IPv6 address, remember where you're going to, that's the destination. So the destination is this local area network over here, and the IP address is 2030 A30 triple B dot double colon 1. So we also do that 2030 A30 triple B double colon 1 slash 64 double colon slash 64. And we also want to specify the next hop IP, which is the next hop IP is going to be the IP of interface gig 0/1, which is 2001 BB9 100.1 double colon 1. So we say 2001 double colon BB9 double colon 100 double colon 1, 2001 BB9 100 double colon 1. Oops. So we did not add the second double colon, so 1. So by doing this, the traffic has left this local area network and it has gotten to this local area network. So we can test the configuration by just going back to the previous device we tried to ping and it was not able to get to that device. We were seeing destination host unreachable. Let's also try it one more time. And now you're seeing request timeout because we've not configured on this local area network, because the traffic is able to get to this destination, but it does not know how to come back to this device that is trying to get a confirmation or trying to communicate with the server. So previously you were seeing destination host unreachable. Now you're seeing a request timeout, meaning there is something wrong, and the only thing wrong right now is because we've not configured on this router to send the traffic back from the way it came. Remember, it came from this router, it went to the second router before it got to the final router. Now we also have to configure a path to send the traffic back to the device that wants to know, or the device that wants to communicate with the server. So what we do is we configure from here back to this router over here. So on this router, we say configure terminal IPv6 route. Previously we were configuring this local area network as a destination. Since we want to be sending the traffic back, the destination has shifted to this local area network, and this local area network has the IPv6 address of 2010 A10 BBB double colon 1. So 2010 double colon A10 double colon triple B double colon 1 slash double colon slash 64. Now we also want to use the next hop IP. The next hop IP is going to be this the then this router, I think that should be interface gig 0/1. So that's interface gig 0/1, and the IPv6 address of that interface is 2001 BB9 100:2. So we head over to this, we head over and we say 2001 BB9 100:2. I believe that's 2 on interface gig 0/1. Yes, that is 2. So the destination IP address, or the destination IPv6 network, and the next hub IP as we have over here. So we click and we just copy this and try to just paste it there. So we are going to be fast. So on this router, remember we have to configure the path back to this router over here. So on this router, since it's directly connected to where we are going to, we are just going to use the next hub IP. So we just paste the configuration that we copied, and the next hub IP address would be interface gig 0/1 that has the IP address of 2002 BB9 100:1. So we are going to change the IPv6 address. So this should be 1 and this should be 2002. By doing this, guys, we've configured a static route for IPv6, enabling these host devices on this local area network to communicate with this local area network devices. And when configuring static routes, we define the path manually because we are the ones who configure what route a traffic should take for it to get to its destination. So let's go ahead and try from this device one more time. Previously we got destination host unreachable. Then secondly, after we configure the path to the destination without a route bringing it back, we got request timeout. Now what do we get now? What we got now is our communication was successful, as you now understand that once you configure a static route going to a particular destination, you also have to configure a route that is going to bring it back to the device that wants to communicate with the other local area network. So you can also say do show IPv6 route, and you're going to see the path that it is taking to get to the destination. So we have 2002 BB9 100.1. We also have 2010, as well as we have another 2010, 2030. So this is the static route for this local area network to communicate with this local area network. Guys, if this video helped you, why not smash the like button, and be mindful that on the next video we'll be talking about another routing protocol that enables local area devices to communicate with each other. Thank you guys, and see you in the next video.